que hemos visto hasta ahora. ¿Okay? Así que deme un momento. Voy a compartir la pantalla. Deme un break. Usted me va a decir si se ve. ¿Se ve lo que estoy compartiendo, estudiante? ¿Alguien me puede decir? Ok. Pues voy a compartir la presentación de hoy. Este tema, esto no viene en el examen. ¿Okay? Esto no viene en el examen. Pero este es material, ¿verdad? Para el próximo, ¿verdad? Examen o lo que sea. ¿Okay? Así que hoy vamos a comenzar Chapter 2. ¿Okay? And we're going to start talking about Lesson 2.1. ¿Okay? This is on your textbook on page 74. Okay? So let's start. Okay? So this lesson is called Using Inductive Reasoning to Make Conjectures. Okay? Let's start with this. Estoy grabando la clase, así que esto va a estar en YouTube. Okay? So let's start. This is not important. Okay? So the objectives for today are the following. Okay? So we're gonna use inductive reasoning to identify patterns and make conjectures. Okay? And find counter examples to disprove conjectures. Okay? So let's start with this lesson. Okay? Okay? The vocabulary word that we're gonna talk in this lesson, we're gonna see what is inductive reasoning, what is conjecture, and what is a counter example. Sorry. Okay. So let's see example 1A. Okay. Identifying a pattern. Okay. Can someone tell me what do you think is a pattern? When you hear the word pattern, what is the first thing that comes to your mind? Can someone tell me? ¿Qué es un patrón? When you hear that word, what do you think of? ¿Me están escuchando? Nadie sabe lo que es un patrón. Nunca la había escuchado eso. Okay, we have here, find the next item. ¿Cómo? Puede ser, exacto, puede ser. Por ejemplo, miren lo que tengo aquí. Exacto. Miren lo que dice ahí, find the next item in the pattern, okay? Ahí tenemos meses del año. Okay, we got January, March, and May. What pattern do you see is following that example, okay? What is the next month that is coming up? Okay, do you see the pattern? We got January. So do you see that we are going 1 month and we are left in 1 month and we're going to the next month, okay? Do you see there is no February there? So we're going January, March, we skip April. So what is the next item after May? July, exactly. Because the pattern is January, we skip February, we go to March, we skip April, we go to May. So we're going to skip now June, and the next month is going to be July, okay? So we are alternating months of the year to make up the pattern, okay? So that's a way that we can make a pattern, okay? We can alternate something to make up the pattern, okay? ¿Entendimos? Ese ejemplo es importante, okay? Let's see another example. So the next month is July, okay? Following the pattern, okay? Okay. Let's see this pattern, okay? Find the next item in the pattern, okay? We got 7, 14, 21, and 28. Can someone see the pattern there that we are establishing? ¿Cómo? Exacto, vamos de 7 en 7, en otras palabras, okay? So it's going to be 7, 14, 28, 28, and the next number is going to be 35, okay? In other words, we are in the table of 7, okay? Si usted puede, ¿verdad? Visualizarlo de esa forma. So we are establishing the multiples of 7, ¿verdad? Los múltiplos de 7. So the next multiple is 35, okay? Because we are saying 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, and 7 times 5 is 35, okay? So that's, students, that's what we basically say that is a pattern, okay? Un patrón repetitivo, okay? So let's now see a pattern with figures, okay? With geometric figures. We got a triangle there. What is the next triangle position in this pattern? Can someone tell me? Do you see the first one is up? The second one is to the left. The third one is down. And what position will be the next triangle? What do you think? Esto es como pensar. You have to think what is the next position, sorry. To the right, exactly. Because we're going up, left, to the south, if we can say it, and to the east or right, okay? So in this pattern, the figure rotates 90 counterclockwise. Do you see that? ¿Verdad? Se mueve 90 grados hacia la izquierda. ¿Por qué dice counterclockwise? Can someone tell me why is said that counterclockwise? What is the meaning of that? Hay que escribir en el chat, vamos a ver. Exacto, va en contra de la manera, ¿verdad? Usted sabe que el reloj, ¿verdad? The clock moves to the right, but we're seeing counterclockwise. ¿Por qué? Porque se mueve a la izquierda. ¿Lo ven, mi gente? Voy a hacerle un dibujo para que lo vean, okay? So, when you have a clock, this is how, let me do a, okay? The clock moves to what direction? To the right, ¿verdad? From this direction. So what is counterclockwise? Well, counterclockwise will move to the other direction. ¿Lo entendimos, mi gente? It will move to the left. ¿Lo vimos? Okay. So that's why I said that it's counterclockwise. So the next figure is going to be to the right, okay? So students, this is what we basically talk about patterns, okay? In your textbook, you have other examples on page 74, okay, that you can look to them, okay? But these are some other examples, okay? So let's do this example that is also on your textbook, okay? So we got a pattern of decimal numbers, okay? We got decimal notation. So what is the next number? Let's see the pattern. We got 0.4. We got then 0.04. We got after that 0.004. So what do you think is going to be the next pattern? What do you see that we are creating here? Can someone tell me? What do you see that we are adding to this pattern? A 0 after the point, right? After the decimal point. So we got 0.4. So then we add 1 0 after the point, the decimal point. And after that, we add another 0. So we're reading the pattern from left to right. The next item in the pattern has one more 0 after the decimal point. So the next number is going to be 0.0004. Do you see that? Okay, we're adding 1 0 after the decimal point. Okay, so the next item will have 3 zeros after the decimal point. In other words, it will be 0.0004. Okay, do we understand this? So these are the first example that we're gonna see today. How to identify patterns or how to create a pattern. Okay. ¿Alguna pregunta, mi gente? That's how basically you work with patterns, okay? O patrones repetitivos. Alguien me dijo que algo que usted repite, pues sí, es algo que se va a repetir y que, ¿verdad? Preguntas hasta aquí. There's any questions? Okay. This presentation will be on LMS also, okay? So you can look for it. Okay? And I am also recording this class, so it's going to be on YouTube, okay? So, otra cosita, recuerde que las clases están en YouTube, ¿ok? Usted puede ir a mi canal y ver las clases, ¿ok? Las últimas clases que hemos dado, ¿ok? ¿Estamos? Así que, that's for your benefit. You can do that. You should do that, ¿ok? Debería ver los videos, ¿verdad? Okay, so let's continue, ¿ok? So we got that clear, okay? That's how we identify a pattern. So now we're gonna talk a little bit about inductive reasoning, okay? So when several examples from a pattern and you assume the pattern, we continue, you are applying inductive reasoning, okay? So inductive reasoning, we apply it in the examples after this, okay? Or before this, sorry. It's based on previous experience assumed to be true, okay? So what the examples that we saw some minutes ago, we apply inductive reasoning and we didn't know we apply it, okay? So that's how you learn, by discovery, trial, and error, okay? When you are working with a pattern, you have to discover what is the next pattern or the next piece of the pattern that is coming up, okay? So you may use inductive reasoning to draw a conclusion from a pattern, okay? So what are the conclusions we make in the patterns? For example, when we did the month pattern that we're going to January, March, what was the inductive reasoning that we applied, or what was the conclusion, sorry, that we induct from that pattern? That we're going from January to March, so we're skipping 1 month, okay? So we are alternating the months, okay? So that's how we apply inductive reasoning, okay? So inductive reasoning, in basic words, is how you are based on a previous experience and you assume that to be true, okay? So inductive reasoning can help us draw a conclusion, okay, a conclusion from patterns, okay? So a statement that you believe to be true based off inductive reasoning is called a conjecture, okay? So conjecture means that this is based on inductive reasoning. So in other words, we can say that a conjecture is not always true, okay? Because it's a statement that you believe to be true based on inductive reasoning. So if you do inductive reasoning and you do an error in your reasoning, what's going to happen to the conjecture? That the statement you believe is going to be false, okay? ¿Entendimos eso? So a conjecture is a statement that you believe is true based on your observation in the pattern. ¿Ok? ¿Entendimos eso, mi gente? So that's what we call inductive reasoning and conjecture. Okay, pregunta hasta aquí. Any questions about these terms? Okay, that is also in your textbook, so you have to read section 2.1. Usted siempre debe mirar el libro, okay? Okay, so let's complete the conjecture, okay? Can someone read that example, please, quick? Complete the conjecture. Can someone read the example, please? Is, okay, thank you. So we got the sum of two positive numbers is, for example, list some examples and look for a pattern, okay? We got 1 plus 1 is 2. 3.14 plus 0.01 is 3.15. So what do you think? So the sum, of two positive numbers is positive, okay? You see, that's how we apply inductive reasoning, because we have to have a previous knowledge so we can answer the conjecture, okay? So we can say that the sum of two positive numbers is positive, okay? And we can look at the example in our mind and see, okay, if I have the sum of two positive numbers, obviously the answer is going to be positive by the rules of positives, okay? ¿Entendimos eso? So that's how we complete, or that's how we do conjectures, okay? Questions about this example? Okay? It's just knowledge, okay? It's like critical thinking. You have to think and answer, okay? Okay. Let's see this another example, okay? We got the number of lines formed by 4 points, no 3 of which are collinear is, okay? So we got to draw 4 points, make sure no 3 points are collinear, so count the number of lines formed, okay? So we're gonna have something like this, okay? If we got this, we draw 4 points. We got the number of lines formed by 4 points. No, 3 of which are collinear is 6. Okay, so we are working with 4 points. Okay, y ninguno puede ser colinear. Okay, so the number of lines we form by 4 points are 6. Okay, so we got A, B, A, C. Okay, we are talking about the combinations that we can have. Okay, y no puede ser. Okay, no 3 of which are collinear is 6. Okay, so that's how we work with conjecture. Okay, we got to have previous knowledge of what we're talking about and apply it to see the conjecture of the possible answer to a problem, okay, or to a pattern, okay. Okay, let's see this example. The product of two odd number is, so when we're talking about odd numbers, we're talking about the opposite of even numbers. So we're talking about numbers that are odd, okay. ¿Alguien sabe lo que son odd numbers? Can someone tell me what are the odd numbers? Do you have heard that word in past math class? ¿Alguien sabe? Podría ser, pero te voy a dar la definición, ¿ok? Solo, te voy a decir cuáles son los odd numbers y cuáles son los even numbers. ¿Ok? The even numbers, pero eso que dijiste está muy bien, ¿ok? The even numbers are the following, ¿ok? Are the numbers that have 0, 2, 4, 6, and 8, ¿ok? So the odd numbers are the numbers that are not even, ¿ok? That cannot be divided. So the odd numbers are 1, 3, 5, 7, and 9, and you got the 11. Okay. In other words, odd numbers are numbers that are prime or composite. Okay. Have we heard about that concept? Okay. What is a prime number and a composite number? Okay. This is previous knowledge that we're supposed to know. Okay. Prime number is a number that you got the result just by multiplying by itself. Okay. For example, 3 is a prime number. The only way you can get to that prime number is by multiplying by 1. Okay. You cannot get to the product of 3 by multiplying by another number. So number 4 is prime or composite. What can you say? Knowing this, number 4 is prime or composite. Can someone tell me? Prime. Are you sure? We can get to 4 by 2 ways. 1 times 4 and 2 times 2. So if a number has one or more product or more than one multiples, it's a composite number. Okay. Se le olvidó esto. Se supone eso se da en quinto grado, en sexto y en séptimo. Okay. So I'm just remember you. What? Okay, but this is all material, okay? What I'm talking about, even, odd, prime, and composite, okay? So let's continue, okay? So for example, the product of two odd numbers is, let's see, is, the product of number is odd, okay? We can see it there, okay? 1 times 1 is 1. 3 times 3 is 9, okay? 5 times 7 is 35. So in this problem, students, we got to know what is an even number and an odd number. So we got to know basic math so we can apply what is a conjecture, okay? ¿Entendimos? Okay? El producto de dos números impares es impar, okay? ¿Estamos? ¿Sí o no? ¿Lo vimos? We got other examples in our textbook, so we can look to them also. Okay, vamos a continuar. Okay. Let's see this example. Make a conjecture about the lengths of male and female whales based on the data. Okay? So we're talking about the average whale length, ¿verdad? Tenemos unas ballenas y estamos viendo cuán largas son las ballenas. Let's see if we can establish a conjecture here. Okay? So we got the length of female, 49. What do you see in the females that is happening? Okay? Or what can you establish by looking through the length of female and males? Okay? We can see, okay, that in 5 or 6 of the 6 pairs of numbers above, the female is longer. Do you see it? So let's see it. In the first case, the female is longer. Do you see it? 49 is bigger than 47 feet. In the second pair, we got that 51 is bigger than 45. Okay. In the third case, we got 50 feet and 44 the male. Okay. So also it's bigger. So what is the only case in which the male is longer or has a bigger length than the female whale? Do you see it? ¿Cuál es el único caso? ¿Quién me dice? El último, 48 feet is bigger than 47, but just by 1 feet or 1 foot. Okay, so that's very interesting. So that's how we apply conjectures. Okay, so female whales, we can say, by this example, we don't know if this is real, but we can say that female whales are longer than male whales. Okay, that's an interesting fact because that's how we apply conjecture. Okay, we look to a pattern and we establish something that is true based on what we saw on the pattern. Okay, so students, this is how we basically do conjectures based on patterns. Okay, on identify a pattern. Any questions about this? Okay, this is really interesting. Okay, this can also be applied to real life situations. Okay, we're talking about whales here, so that means we're talking about zoology or biology. So we're applying that to this geometry lesson. Okay, that's interesting. Okay. Okay. So to show that a conjecture is always true, you must prove it. Okay. You must prove it to show that a conjecture is always true. Okay. So how do we show that a conjecture is false? You have to find only one example in which the conjecture is not true. This case is called a counter example. What do you think is a counter example? For example, if we got an example, if we make a counter example, that's an example that makes that example false. Okay? So a counter example is an example that we use to make a conjecture false. Okay? To show that a conjecture is false and is not true. Okay? So when we hear the word counter, we are talking about the opposite of the example. Remember, when we talk about counterclockwise, we're talking about going to the other way of the clockwise. The clockwise goes to the right, but a counterclockwise will go to the left. So that's what we say is a counter example. Okay? So a counter example can be a drawing, a statement, or a number. So that's what we're going to do now. We're going to make conjectures false because to show that a conjecture is true, you must prove it. Okay? So that's important that we know it. We are working now with counter example. What is a counter example? So the way we apply inductive reasoning is the first thing we have to do that we saw in this presentation is look for a pattern. Okay? That's the way. That's the first step always. We got to look for a pattern. Second step of how to apply inductive reasoning is to make a conjecture. Okay, is to make a statement. Okay, is to make a statement to see if it's true. Okay, and the next thing we got to prove the conjecture to say it's true or find a counterexample that it proves that it's false. Okay, so these are the three basic steps that we're gonna do to apply what we call inductive reasoning. Okay, let's see how do we apply or how do we find a counter example to make a conjecture false? Okay, so let's see this example. Example 4a, finding a counter example. So show that the conjecture is false by finding a counter example. So we say that for every integer n to the square, n to the power of 3, or n cubic is positive. Okay, so we're gonna pick an integer and substitute them into the expression to see if the conjecture holds. Okay? For example, let's see this. Let me write this in so you can see it. Okay? Ustedes saben lo que estoy hablando, lo que me refiero cuando hablo de esto, ¿verdad? If we're talking about n3, we're talking about any number, okay, that we are evaluating the integer. So when we're talking about integer number, who remember what is an integer? ¿Qué es un número íntegro? ¿Alguien se acuerda de su álgebra 1? What is an integer? Okay, an integer is all the positive numbers, 0 included, and all the negative numbers. Okay, so let's see if this is true. Okay, for example, if we are evaluating, we are trying to make a counterexample. We are trying to make this true or false. If we got 2 to the power of 3, what's the answer of 2 to the power of 3? Can someone tell me? 2 to the power of 3 is the same as saying 2 times 2 times 2, okay? So what is the answer of 2 times 2 times 2? What's the answer of that multiplication? 8, thank you. Okay, let's see an example now of the same integer but negative number. Okay, so if we pick an integer, for example, 5, negative 5 to the power of 3, let's evaluate this one now. So we got negative 5 times negative 5 times negative 5 times negative 5. Okay, if we do that, we're gonna see that negative 5 times negative 5 is 25. Okay, that's true or false? Negative 5 times negative 5 is 25. So what's the answer, students, of 25 times negative 5? Can someone tell me? What's 25 times? ¿Cuánto? Thank you. So we saw here that the statement is not always true. So that's how we do a counterexample, because the statement says for every integer n, that n to the power of 3 is positive. So that is not always true. When we evaluate different integers, we notice that when we are working with negative numbers, the answer is not going to be positive. It's going to be a negative answer. Otherwise, when we're working with positive numbers, it's always going to be positive. But aquí es que está el error. Dice for every integer. That means it doesn't matter what integer you pick up, it's supposed to give you positive. So that's how we apply it. Here, it chooses negative 3, but we see the same thing. Negative 3 to the power of 3 is 27. So the statement, ¿verdad? The conjecture is false. ¿Entendimos? That's how you prove that a conjecture is false, by finding a counterexample. Okay? So in this lesson, we got to know some math stuff or math skill that we're supposed to know. Okay? Así que repase esas destrezas básicas. Okay? For example, what is a number? What is an even number? What is a prime, composite? What is an integer? We're supposed to know this. Okay? ¿Verdad? Los integers son todos estos números. 0 is included, all the positives, todo lo positivo, ¿verdad? Esto sigue al infinito positivo, okay? And all the negative numbers, okay? We're supposed to know that. I'm just reviewing it very quick, okay? Because we saw that in algebra. We're supposed to see that or saw that in algebra 1, okay? Any questions about what is an integer? Lo vimos, mi gente. This is basically what we call an integer, okay? Preguntas, dudas, mi gente. ¿Estamos? ¿Alguna pregunta, observación? Okay. So that's how we work with making a conjecture false by finding a counter example. Okay, let me continue. We're almost done for today. Okay, so -3 is a counterexample. Okay, but I give you another counterexample. -5 is a counterexample also. So you have to find one counterexample. But there are many, or there are multiple counterexamples that you can have. Okay, let's see one more. Okay, okay. So this example says, show that the conjecture is false by finding a counterexample. So look what we have. We got that two complementary angles are not congruent. Let's see if this is true or, okay, when we talk about complementary angles, we say that 45 plus 45 is 90. So that's what we call a complementary angle. So if the two congruent angles both measure 45, the conjecture is false. Why? Why is that? ¿Alguien me puede decir por qué eso es falso? Recordando lo que vimos en las pasadas clases. Esto lo discutimos. Can someone tell me? Because the statement says that two complementary angles are not congruent. ¿Qué significa congruent? ¿Quién me dice? What is the word congruent? We saw that in lesson 1.4. ¿Alguien se acuerda? What is congruent? Congruent is that they have the same measure. So for example, if we pick this example, 45 plus 45, we got the same measure. So 45 angle 45. And the angle that has 45, both of them are congruent. So this statement is false because two complementary angles can be congruent. ¿Ok? ¿Entendimos eso? Así que ese conjecture is false. Okay? The counterexample is the following. You can also pick another measure, for example, but this is the right measure, okay? Because 45 plus 45 is 90. Remember, complementary angles are angles that are two angles that have the measure of 90 degrees, okay? Estamos. So if the two congruent angles both measure 45, the conjecture is false because there can be complementary angles that are congruent, okay? Let's see another example. Show that the conjecture is false by finding a counterexample. So we got that for any real number, x is greater than or equal to x. Okay, so let x be 1/2. So 1/2 to the power of 2. Okay, when we evaluate 1/2 to the power of 2, we're gonna have that it's gonna be 1/4. So 1/4 is not equal to 1/2. So that's how we work this example, students, okay? So we pick, it says any real number. So the real numbers are all numbers, okay? So if we pick a fraction, for example, 1/2 to the power of 2, if we evaluate that, we're gonna see that this statement is not true. Any real number is not gonna be real, okay? So for any number, this is not real, okay? Okay, so the conjecture is false, okay? The last example we're gonna see is supplementary angles are adjacent, okay? We know that a supplementary angle is two angles that measure 180. So for example, we got this angles. The first angle has a measure of 23 degrees, and the next angle has a measure of 157 degrees. Okay, so we see that these are supplementary angles, but are not adjacent. So the conjecture is false. Okay, so this is not what we're gonna work. Voy a decirle lo que va a trabajar ahora. Okay, any questions about this?